Hi, my name is Tshivenḓa. I'm a PhD student at the University of Witwatersrand and at the School of Statistics and Actuarial Sciences. This is a presentation on the paper titled MphyaNER, Named Entity Recognition for Tshivenḓa. I worked with a group of authors with Rand and Mbova being the corresponding author. Named entity recognition involves identifying named entities in text. This could be person names, organizations, locations, dates, and so on. Named entity recognition is important in several natural language processing tasks like information retrieval, text classification, and problem answering. However, named entity recognition can be difficult, particularly in low-resource languages that have limited annotated datasets and tools. This paper seeks to contribute to addressing these challenges by presenting MphyaNER, the first Tshivenḓa NER corpus in the news domain. Tshivenḓa is a minority language spoken by about 1.3 million people, mainly in South Africa and the surrounding regions. Tshivenḓa is part of the Southeastern group of Bantu languages, and named entity recognition activity in Tshivenḓa has been limited to Sadila corpus, which is primarily restricted to named entities in the government domain. The data for this study was obtained from Vukuzenzele news articles, which is a monthly newspaper published in multiple languages by the South African government's communications unit. The data was originally in PDF format and was converted to text files, cleaned and standardized by the Data Science for Social Impact research group found at the University of Pretoria. The MphyaNER corpus was created by manually pre-processing the text files to reduce errors in text extraction. In terms of methodology, we benchmarked our work by fine-tuning multiple pre-trained language models, about 5 models. And then we also did zero-shot adaptation of Massacre NER 2.0 corpus and Sadila in Tshivenḓa NER corpus. Lastly, we did augment MphyaNER corpus by co-training with some Bantu languages. Here are the results of the study. Starting with the data set. So the data set was split into train, dev, and test. And in total, we had 1,339 sentences with 40,778 tokens in total. So from the results that we observed using the baseline models, so in this study, we used the F1 score as the evaluation metric. And the higher the F1 score, the better the performance of the model. So from the 5 benchmark models that we performed, we observed that they all struggle to identify the date entity. However, there's quite a good performance that we observe on location, organization, and person. And we also note that AfroXLMR large does give us the best F1 average score of 71.0. And we also note that the more we increase the capacitor size of AfroXLMR model, the better the performance that we get. What we then did was to do zero-shot transfer learning using Massacre 2.0 corpus, which was trained on several South African languages. And the 4th transfer languages here are Shona, Kiswahili, Setswana, isiXhosa, and isiZulu. We did take out the date entity for cross-domain experiment purposes. And what we observed is that there's quite a significant drop in terms of performance for all of these models. However, we do know that Setswana and Kiswahili does give us like a better F1 score on average. What we also did here was to to do an adoption of the dealer Tshivenḓa NER corpus based on government data to MphyaNER corpus. And what we observed here is the F1 score, average score of 35.2, which is the worst in this scenario. And this doesn't indicate that the difference in domain has a big effect on transfer performance. Following up on what we did on the previous slide, we then chose top 3 transfer languages, which are Xitsonga, Kiswahili, and Setswana. And we also included the date entity. And what we observe here is that there's quite a good performance from Xitsonga and Kiswahili on the date entity. And Setswana does give us better results on the location entity. However, all of these models, they struggle with identifying organization and person. And on average, Setswana and Kiswahili does give us better results in terms of transfer. Lastly, what we did here was to perform co-training experiments by combining the MphyaNER corpus with Xitsonga, Kiswahili, and Setswana. And what we observed there is that there is quite a significant improvement in terms of the F1 score when we do augment MphyaNER corpus with these languages. In conclusion, this study investigated zero-shot transfer learning between Tshivenḓa and other Bantu languages. The results show that Setswana and Kiswahili provide the best zero-shot transfer learning performance. And we also observed that augmenting the MphyaNER corpus with Xitsonga data does improve model performance significantly. Thank you.